Steps involved in computer problem solving. Before we write a program, we need to learn the basic objective of it. Why do we need a program and what purpose does it solve? To solve this problem of writing a program, we follow some steps as given below. 1. Understanding the problem. This is a very important and difficult step where we need to understand the main objective of a problem. Give more time to this step, as the better you understand the problem, the easier it will be to solve it. 2. Analyzing the problem. In this step, we analyze what kind of data can be given as an input, what formula or tool to use to do the processing, and in which format the output will be displayed. 3. Developing the solution. We can use problem-solving tools like algorithms or flowcharts to design the step-by-step instructions for developing the solution of a given problem. It is always recommended to first write an algorithm and draw a flowchart for solving a problem and then only write the program. 4. Coding and implementation. This is the last step where every instruction of an algorithm is converted into a computer-understandable instruction by using the syntax and semantic of a specific computer language. Control structures. Control structures are a set of instructions that controls the flow of instructions in a program. It is a programming tool that determines the order of execution of the statements in any programming language. There are 3 different types of control structures: sequential flow, selection flow, and repetition flow. Let us learn about these in detail. Sequential flow. In sequential flow, the statements are placed one after the other and the flow of execution occurs starting from line 1, line 2, and so on with a top-down approach. It is the default flow followed in any programming language. For example, steps for calculating percentage of any student are: 1. Input marks of English, Hindi, and Math. 2. Total the marks. 3. Calculate the percentage. 4. Display the percentage. Selection flow. Selection flow is also known as branching control, as the flow of control branches based on a condition. A condition evaluates to either true or false. In the case of true, the flow of control follows the set of instructions written for true. In case it is false, then it follows the other route. For example, if we consider the above example, where we have a condition, award to be given if the percentage is more than 90 only. 1. Input marks of English, Hindi, and Math. 2. Total the marks. 3. Calculate the percentage. 4. Display the percentage. 5. If percentage is more than 90, then display award given. Otherwise, display no award. Repetition flow. Repetition flow is also known as loop, as it repeats a set of instructions a number of times based on a condition. For example, if we wish to repeat the above steps of calculating percentage for 10 students, then we follow the concept of repetition. 1. Repeat for 10 people. Input marks of English, Hindi, and Math. Total the marks. Calculate the percentage. Display the percentage. If percentage is more than 90, then display award given. Otherwise, display no award. 2. Go up again till number of repeat is less than or equal to 10. Algorithm. An algorithm is a step-by-step approach to identify and solve a problem in a finite time. It is used in the problem-solving phase of any programming task and helps in defining the clear instructions in sequence. An algorithm uses simple English-like statements to represent the steps of a program. There may be more than one way to solve any problem. So there may be more than one algorithm for a given problem. It must terminate after a finite number of steps. Once we have an algorithm, we can translate it into a computer program in any programming language. Writing an algorithm. Let us do an activity of writing an algorithm for making cucumber and tomato sandwich. Step 1. Take few slices of tomato and a cucumber. Step 2. Take 2 slices of multigrain bread. Step 3. Put tomato sauce on 1 slice. Step 4. Put cheese bread on another slice. Step 5. Place a few slices of tomato and cucumber between the 2 slices of bread. Step 6. Cut it into 2 halves and serve it. Advantages of an algorithm. Advantages of an algorithm are as follows. It is a step-by-step representation of a solution to a given problem. It uses simple English-like statements, so it is easy to understand and write. The problem is broken down into smaller pieces. Hence, it is easy to convert it into a program using any programming language. Disadvantages of an algorithm. Disadvantages of an algorithm are as follows. Since there is no standard rule for writing an algorithm, it varies drastically. It is a time-consuming process. It is difficult to represent branching and looping in an algorithm. Let us look at some examples of algorithm. 1. Input the temperature in Fahrenheit and convert it into Celsius and display it. Start. Input temperature in Fahrenheit. C is equal to 5 by 9. Temperature minus 32. Display C. Stop. 2. Input the radius of a circle and calculate its area. Start. Input radius. Area is equal to 3.14 multiplied by radius multiplied by radius. Display area. Stop. 3. Input an age and check whether eligible for driving license or not. Start. Input age. If the age is more than or equal to 18, then display eligible. Otherwise, display not eligible. Stop. 4. Display even numbers from 2 to 20. Start. N is equal to 2. Repeat for n is less than or equal to 20. Display n. N is equal to n plus 2. Go to repeat till n reaches 20. Stop. Flowcharts. A flowchart is a graphical representation of an algorithm. It makes use of symbols which are connected through arrows to show the direction of flow of information. It has been proved scientifically that visuals have more impact on the human brain as compared to text. So, flowcharts are preferred over algorithms for solving a problem. The symbols are symbol names, symbols, purpose, oval, used to start and stop a flowchart, parallelogram, used to take input and display output, rectangle, used to perform assignment, mathematical and processing operations, diamond, used for decision making in case of branching or looping, arrow in any direction, used to show the direction of flow of information in a flowchart. Drawing a flowchart. Let us make a flowchart for calculating the area of a circle. Advantages of flowcharts. Advantages of a flowchart are as follows. It is a better way of communication due to its graphical representation. It is an effective way to solve and analyze a problem. It is an easier method of converting a program logic into a code using any programming language. The flowchart makes program or system maintenance easier. It is used in preparing documentation of an application or a process. Disadvantages of flowcharts. It is a time-consuming process. It is difficult to make flowcharts for complex and long programs. Modification of the program through flowchart is sometimes time-consuming. If we have to represent branching or looping in flowchart, then we use a diamond symbol with directions as yes or no. Let us try to find out the age for driving license using a flowchart. If we have to repeat the printing of hello 5 times, then the flowchart for this kind of looping will be difference between algorithm and flowchart. Let us look at the differences between an algorithm and a flowchart. Algorithm, flowchart. It is a step-by-step textual approach to solve a problem. It is step-by-step visual or graphical approach to solve a problem. It is a pseudocode, false code of a program. It is a graphical representation of a program. Difficult to represent branching and looping. Easily represents branching and looping through symbols. Easy to find errors. Difficult to find errors. Can be used for simple, complex, or long processes. Advisable to use only for simple processes. What is Code Combat? Code Combat is a free coding educational game that teaches you to learn JavaScript or Python coding in a fun way. It is available for all age groups to suit the needs of all levels of coding and computer science learners. There are self-paced games with practice levels and hints in case you get stuck. If you master the skill of coding, then there are few challenge levels also. It is equivalent to doing beginners level courses in any programming language. There are 2 coding programs. Code Combat. It is the company's original coding game recommended for parents, individuals, educators, and students. Ozaria. It is an adventure game, fantasy story, and computer science program recommended for educators and students. Using Code Combat. Perform the following steps to use Code Combat. Step 1. Open the following link. https://codecombat.com/. Step 2. Click on the I am a student button. A pop-up appears asking for class code. Step 3. Enter the class code if you have. Otherwise, click on the play button. This class code is required when you want to play the game with your class. Your teacher can provide you a class code. When you click on the play button, the main screen of the Code Combat game opens. Step 4. Click on the play button. The next screen will display that there are 44 levels in the game. A yellow color arrow pointing on a red flag signifies the starting point of the game. Step 5. Click on the red flag, a pop-up appears, displaying the things to do while playing the game. Step 6. Click on the play button. The Choose Your Hero screen appears from where you need to choose the hero with which you want to play the game. Step 7. Select the desired hero from the available heroes. Do not change the default programming language, which is Python by default. In this case, we have selected the Sartharine Thunderfirst hero. Step 8. Click on the next button. The inventory screen appears from where you can select different items and equipment to improve the performance of your hero. Step 9. Double-click on the equipment to select all. Step 10. After selecting the equipment, click on the play button. The next screen shows the goals of the level. Step 11. Click on the Start Level button. Next screen will allow you to type the code to move the hero. Step 12. Type the desired code and click on the Run button. Step 13. Once you have completed the level, the Done button appears. Step 14. Click on the Done button. The next screen will show that you are the winner. Step 15. Click on the Continue button to go to the next level. What is Python? Python is a general-purpose, object-oriented, easy-to-learn and high-level programming language. Guido van Rossum designed Python and released it in 1991. He wanted to give a unique name to it, so he named it after the famous BBC comedy TV show Monty Python's Flying Circus. Python as a language supports simple English-like statements, making it easy for the programmers to learn and maintain. This is one important reason for its popularity. In this chapter, we will learn a few other important features and the basic concept of programming through Python. Important features of Python. Python is a very popular programming language. Let us study some of its important features to find out the reasons for its popularity. High-level language. Python is a high-level and general-purpose programming language which simplifies the process of developing a program. The code written in Python is more close to human language and away from machine language. Easy to learn and use. Python has simple English-like statements which are easy to learn and use. Anybody can easily get used to its syntax and can expertise in it. Expressive language. Python supports simple code that expresses itself in a few lines to do big and complicated tasks. Free and open source. Python code is developed under OSI-approved open source license, which allows it to be downloaded free of cost from its official website, https://www.python.org. The code can be modified and distributed further even for commercial purposes. Cross-platform language. Python supports multiple platforms like Windows, Linux, Macs, Raspberry, Pi, etc., which means a code written in one platform can easily run on another platform with little or no changes. Interpreted language. Python uses an interpreter where the source code is converted and executed line by line at a time. Object-oriented language. Python supports the concept of classes and objects that make its code efficient and reusable with important features like polymorphism, inheritance, data encapsulation, etc. Supports GUI. Python supports graphical user interface, which makes it more user-friendly and easy for the programmers to design code. Large standard library. Python has some built-in modules and packages for doing some standard and common tasks. These important libraries make it popular especially in AI-based programs where we need to focus more on its use and not in its core design. Role of Python in artificial intelligence. Python is most popular language for artificial intelligence is based on the facts given below. Built-in libraries. Many built-in modules and packages in Python reduces development time and effort to design code for artificial intelligence. There are NumPy for scientific computation, PyBrain for Python machine language, SciPy for advances computing, Pandas for general-purpose data analysis, and many more. Platform independence. Python has this versatile nature of running the code in any platform, like Windows, Mac OS, Linux, Unix, etc. Packages like PyInstaller can be used to prepare the code that can run on different platforms. Extensible. We can add low-level modules to the Python interpreter that helps a programmer to customize their tools in an efficient manner. Availability of data analysis tools. Libraries like Matplotlib helps data scientists to build charts, histograms, and plots them for easy comparison of data, which is important for creating data analysis reports with visual effects. Community support. Python, being one of the popular languages, has attracted a lot of developers to design online forums and online tutorials to provide assistance related to different types of programming in Python. This community support has worked to be an important factor for using Python in AI design. Important uses of Python. Following are some uses of Python. Used for web and internet application development. Python has pre-built libraries and web frameworks like Pyramid, Django, and Flask, which are used for backend web development projects. Some standard libraries also support content design, database connectivity, and many internet protocols like HTTP, SMTP, XML, etc. Scientific and numeric calculation. Scipy, Pandas, IPython are some of the built-in packages in Python which are used for scientific and numeric calculations. Game development. PySoy, a 3D game engine that supports Python 3, and Pygame are two Python-based libraries used widely for game development. Most of the popular games like Battlefield 2, Fritz on Fire, World of Tanks, Disney's Toontown Online, etc. are designed using Python game libraries. General-purpose software development. Python is used for all-purpose software development. It also supports audio and video files that help in designing multimedia applications. Installing Python. Windows does not come with Python as default installed in it. We need to download from the official website. The steps to download and install Python are: 1. Open the official website https://www.python.org/downloads. 2. Click on the Download Python 3.9.x button. The installer file will start downloading. 3. Click on the Setup file to start installation. The Python Setup wizard appears. 4. Select the Add Python 3.9 to Path checkbox and click on the Install Now option. After the setup progress is complete, then the given message will be displayed showing Setup was successful. Now Python is available in your Start menu and also as a shortcut on the desktop. When you open the Python idle shell window opens. IDLE stands for Integrated Development and Learning Environment. It is a code editor which helps you to write and execute Python programs in the editor itself. Working in Python. We can interact with Python in two different modes. Interactive mode. Python idle shell mode. In this mode, you can type one command at a time in front of the Python command prompt, and Python gives you the result based on the command given. It means you run code directly on the shell mode accessed through the terminal of an operating system. This mode will not save your commands and outputs and should be used only when you want to play with small one-line instructions. You can also use the print function to print the messages on the shell window. For example, Script mode editor. In this mode, you save all your commands together in any text editor with the extension .py. When we run this text file .py, then the output of the commands will be displayed in shell mode. The steps to create and run script file in script mode are: Step 1. Click on the File, New File option in shell mode. A new blank text editor appears. Step 2. Type the commands and then click on the File, Save As option to save the file. The Save As dialog box appears. Step 3. Select the desired location to save the file and type the file name in the file name box. In this case, we have typed the file name as myfirstfile.py. Step 4. Click on the Run module, or press F5 key to run the program. The program will execute and the output will be shown in the shell window. Python character set. A character set can be set of valid characters. For example, digit like 0, 1, 2, till 9. Letters in upper or lower case like A to Z or A to Z in lowercase. Special symbols like $sign, %sign, exponential, and asterisk, bracket, @ exclamation mark, etc. White spaces like spacebar, tab key, or enter key. ASCII or Unicode characters like emoji symbols or other symbols with unique code. Statements in Python. Instructions written in a source code that are executed by a Python interpreter are called statements. There are 3 types of statements in Python, which are simple statements, multi-line statements, and multiple statements. Let us learn about them in detail. Simple statements. By default, the end of a statement is done by pressing an enter key. Each statement is written on a new line. A is equal to 5 is a simple statement, where variable A is created with value 5. C is equal to A plus B. Multi-line statements. We can make a statement that extends over multiple lines by using line continuation character as shown below. A is equal to 4 plus 5 plus slash. C plus 7 plus slash. 8 plus 9. The main advantage of using multi-line is when we need to do long calculations and cannot fit these statements into one line. Multiple statements. Multiple statements represent more than one statement in a single line. This can be done by separating the statements using semicolon. A is equal to 5, semicolon. B is equal to 10, semicolon. C is equal to A plus B, semicolon, print C. Tokens. Tokens are the smallest meaningful unit of a program. Python supports the various tokens. Let us learn about them. Keywords. Words that have special meaning are reserved by Python for special purposes and are not allowed to be used as identifiers. We can see the list of the reserved keywords by giving the following command at the Python command prompt. Import keyword. Keyword.kwlist. Following is the list of keywords displayed by running the above commands. False, class, finally, is, return. None, continue, for, lambda, try. True, def, from, non-local, while, and, del, global, not, with, as, elif, if, or, yield, assert, else, import, pass, break, except, in, raise. Identifiers, names. Identifiers are the user-defined names of variables, list, dictionary, tuples, classes, etc. They identify an element in Python. Naming the identifiers follows rules as given below. An identifier can have letters in uppercase or lowercase, numbers or underscore. It cannot begin with a number or an underscore. No special characters like $, period, space, etc. are allowed. It should not be a Python keyword. Uppercase and lowercase letters are different. Examples of invalid identifiers are first name, spaces not allowed. Last and name, cannot have special character. Underscore class 9th, cannot begin with underscore. 9th class, cannot begin with number. Else, keyword not allowed. Example of valid identifiers are my class, class 9, address, first underscore name, city, student underscore ID, data 123, underscore class 9th. Variables. Variable is a name given to a memory location to hold a specific value. It is just like a container that can hold any type of data that can be changed later in the program. Variable has a name that follows the rules of identifier naming conventions and is case sensitive. A value that can be integer, float, string, boolean, etc. Unlike other programming languages, variables in Python are not created before. They are created automatically when a value is assigned to it using equal to operator. A variable assigned with a value of one type can be reassigned a new value of a different type as shown below. There are different ways of assigning values to different variables in Python. Method 1. Assigning different values to different variable on different lines. Method 2. Assigning different values to different variable on same line. Or Method 3. Assigning same values to different variable on same line. Data types. Data types specify the kind of a value a variable can store. It helps us to identify the kind of operation that can be performed on that specific data type. Every value in Python has a data type. Some of the standard built-in data types of Python are data types, numbers, sequences, sets, maps. Numbers, int, float, complex. Sequences, string, list, tuple. Maps, dictionary. Numbers. Data with a numeric value falls into this category. It can be integer, float, and complex. Python will automatically convert a number from one type to another if needed. Following are some number types. Integer. Integers are whole numbers, positive, negative, or 0, with no fractions or decimal value. Its length is dependent on the available memory. For example, 10, 124, 4567, 781 crores 25 lakh 68,751. Float. It is a real number with floating point representation. For example, 15.5 and 12.0. It can also be represented using the exponent notation. E, for example, 1e5 is 1 lakh. Complex. It is made up of a real number and an imaginary number. For example, 3 plus 2i, where 3 is a real number and 2i is an imaginary number. None. This is a special data type where null or nothing or no value. It does not mean 0, false or empty. It is represented by none. Sequence. It is a collection of data stored under a common name. Each value is referred by its index number. It can be mutable or non-mutable. There are 3 types of data as sequence in Python. String. It is a sequence of Unicode characters enclosed in single or double quotes. Multi-line strings can be created using triple quotes, single or double. Its length is dependent on the available memory. It can also be empty, where we have just empty quotes with no value. For example, lists. It is a sequence of heterogeneous values arranged as elements and are referred by an index number. These values are separated by comma and are enclosed in square brackets. They are mutable data types as the values of these data types can be changed by the user after creation. For example, tuples. It is a sequence of heterogeneous values arranged as elements and are referred by an index number. These values are separated by comma and are enclosed in circular brackets. They are immutable as the values of these data types cannot be changed by the user after creation. Boolean. It is a data type with 2 built-in values, true or false. It is used in logical evaluation. A true value represents 1, while a false represents 0. Data type conversion. Data of one type can be converted into another type by using conversion built-in functions like int, float, string, etc. The process of converting value of one data type to another is called type conversion or typecasting. For example, you can get the data type of any object by using type function. For example, literals. It is defined as any data stored in a variable. This data can be string literals, are enclosed in single or double quotes. For example, double quotes hello, single quotes Python. Numeric literals. They can be integer, float, or complex. For example, 14, 20.5, 2 plus 5j. Boolean literals. They can be true or false. For example, true. Special literals. Only none is a special literal. It means something not yet created. Punctuators. Punctuators are special symbols used in Python to organize statements and expressions. Most commonly used punctuators in Python are operators. Operators are special symbols used to perform mathematical, logical, and relational operations on variables and values. The variables or values on which the operators work are called operands. Some commonly used operators in Python are arithmetic operators, relational operators, logical operators, and augmented assignment operators. Arithmetic operators. Arithmetic operators are used to perform mathematical operations on variables and values. Following arithmetic operators are provided by Python: name, symbol, purpose, example, output. Addition. Add 2 values. 2 plus 4, 6. 2.0 plus 4, 6.0. High plus all, high all. Subtraction. Subtract second value from the first value. 6 minus 2, 4. 6.0 minus 2, 4.0. Multiplication. Multiplies 2 values. 2 times 3, 6. 1.5 times 2, 3.0. High times 3, high, high, high. Division. Divides 2 values. 4 by 2, 2.0. 6.0 by 2, 3.0. 6 by 2.0, 3.0. 11 by 2, 5.5. Remainder, percentage. Returns the remainder of a division. 5 remainder 2, 1. 16 remainder 11, 5. Exponential. Second number raised to the power of first number. 5 exponential to 25. 1.5 exponential to 2.25. Floor division. Divides the first number with the second number and returns the whole number adjusted left to the number line. 11th floor division to 5. Minus 11th floor division to minus 6. 13th floor division 4, 3. Minus 13th floor division 4, minus 4. Relational operators. Relational operators or comparison operators compare the values given on both the sides of the operators and returns the Boolean value either true or false. Following relational operators are provided by Python. Name, symbol, purpose, example, output. Equal to. Returns true if both the values are same, otherwise false. A equals to 5. B equals to 10. A equals to B. False. Not equal to. Returns true if both the values are different, otherwise false. A is equal to 5. B is equal to 10. A not equal to B. True. Greater than. Returns true if first value is greater than second value, otherwise false. A is equal to 5. B is equal to 10. A greater than B. False. Less than. Returns true if first value is less than second value, otherwise false. A is equal to 5. B is equal to 10. A less than B. True. ABC greater than ABC. True. 67 greater than 621. True. String value are compared using ASCII code. Greater than or equal to. Returns true if first value is greater than or equals to second value, otherwise false. A is equal to 5. B is equal to 10. A greater than equal to B. False. Less than or equal to. Returns true if first value is less than or equal to second value, otherwise false. A is equal to 5. B is equal to 10. A less than equal to B. True. Logical operators. Logical operators are used to combine one or more conditional statements and returns either true or false, based on evaluation of conditions. Following logical operators are provided by Python. Name, symbol, purpose, example, output. And. Returns true if both the operands are true, otherwise false. 5 less than 10 and 2 less than 5. True. Or. Returns true if either the operands is true, otherwise false. 5 greater than 10 or 2 less than 5. True. Not. Returns true if the operand is false. It reverses the result. Not 5 greater than 10 or 2 less than 5. False. Not 10 less than 5. True. Not true. False. Assignment operator. Assignment operator is used to assign a value to a variable or a constant. Is equal to sign is used as an assignment operator in Python. For example, augmented assignment operators. Augmented assignment operators are those operators which take the value of the operand on the right side, perform an operation and assign the result to the operand on the left side. These operators are also known as shorthand assignment operators. For example, if A is equal to 10, then A plus is equal to 5 is the same as A is equal to A plus 5. Python provides the following augmented assignment operators. Symbol, purpose, example, output. Adds first and then assigns the result to the left-hand side operand. A is equal to 5, B is equal to 10, 15. A plus is equal to B, 20. A plus is equal to 5. Subtracts first and then assigns the result to the left-hand side operand. A is equal to 5, B is equal to 10 minus 5. A minus is equal to B. Multiplies first and then assigns the result to the left-hand side operand. A is equal to 5. A times is equal to 5, 25. Divides first and then assigns the result to the left-hand side operand. B is equal to 10. B upon is equal to 5, 2.0. Floor division first and then assigns the result to the left-hand side operand. A is equal to 5, B is equal to 10, B floor division is equal to A, 2. Remainder of a number first and then assigns the result to the left-hand side operand. A is equal to 5, B is equal to 10, A remainder is equal to B, 5. Exponential of a number first and then assigns the result to the left-hand side operand. A is equal to 2, B is equal to 4, A exponential B, 16. Operator precedence. An expression is made up of values, variables, operators, and functions. For example, x minus 5 plus 6 is an expression. To evaluate an expression with multiple operators, Python follows an order of precedence. This order can be altered by writing an expression within parentheses. The order of precedence in the descending order is listed below. Order of precedence. Operators. If an expression contains two or more operators with the same precedence, then order of evaluation is from left to right, except from exponential, which is always from right to left. For example, 10 minus 2 plus 3 minus 3 will be evaluated from left to right as plus and minus has the same order of precedence. So the answer will be 10 minus 2, will be 8 plus 3, will be 11 minus 3, will be 8. 2 exponential 3, exponential 2 will always be evaluated from right to left. It will be calculated as 2 exponential 3 exponential 2 and not as 2 exponential 3 exponential 2. So the answer will be 512. Comments in Python. Comments are used to increase the readability of the code. We use them to give proper understanding of the code in simple English statements. They are completely ignored by the Python interpreter. It is always a good practice to add comments in your code so that if anybody in future wish to understand or modify your code, then through comments, it becomes easy to interpret the instructions. There are two different ways of writing comments in Python. Let us learn about them in detail. Single line comment. Single line comment starts with hash symbol, followed by the text to be written as a comment that lasts till the end of the line. For example, multiple line comments. When we add up comments which occupy two or more lines, then we begin the comment with either 3 times single quotes or double quotes, followed by text on multiple lines, and end with single quotes or double quotes to mark the end of the comment. For example, the print function. The print function is used to print an output on the screen. It converts the expressions into a string before writing to the screen. Syntax to use the print function is print object objects SEP is equal to separator, end is equal to end, where object can be one or more separated by comma and it can be a variable, literal, expression. An object will be converted to string before printed. SEP is used as a separator if there are more than one objects. End specifies what to print at the end. Default is new line, /n. Following are some of the examples of the print function. Commands, output. Print hello, hello. Print hello friends, hello friends. Print hello plus friends, hello friends. This is concatenation of string using plus operator. Print hello friends, SEP is equal to $. Hello $friends. Print hello friends, SEP is equal to $, end is equal to exclamation. Hello $friends exclamation. Print hello friends, end is equal to exclamation. Hello friends exclamation. Print hello. Print friends. Hello friends. Print hello, end is equal to %sign. Hello %sign friends. Print friends. Print hello friends, welcome, SEP hashtag, end @. Hello #friends #welcome @. Print I am in class 9. I am in class 9. A is equal to 5. B is equal to 10. Print sum of two numbers is plus str A plus B. Sum of two numbers is 15. Age is equal to 14. Print I am age years old. I am 14 years old. The input function. The input function is used to take an input from the user. When this statement executes, then the flow of the program stops and waits with the cursor blinking for the user to enter a value. The input given by the user is always a string value in Python. The syntax to use the input function is input prompt, where prompt is a string that works as a message for the user at the time of input. For example, name is equal to input, enter your name, : print name. When the preceding statement executes, it will ask to enter name. When you enter the name and press the enter key, entered name will be displayed on the screen. Enter your name, Chirag, Chirag. Let us take another example. A is equal to input, enter first number. #line 1. B is equal to input, enter second number. #line 2. C is equal to A plus B. Print, the sum is C. If we execute the preceding code and enters 4 and 5 as the values of the first and second numbers, then the answer will be 45 instead of 9. This is because Python considers every input value as string. If we want to perform mathematical calculations, then we have to convert the taken input explicitly by using int or float functions. The syntax to convert an input value into an integer or float type is A is equal to int, input prompt. # to convert into integer. B is equal to float, input prompt. # to convert into float. Let us create the preceding program again by using the int function. A is equal to int, input, enter first number, #line 1. B is equal to int, input, enter second number, line 2. C is equal to A plus B. Print, the sum is C. Now the program will display the correct output as 9. Errors in Python. Sometimes while writing a code we might make mistakes. These mistakes are called errors. There are three kinds of errors which a programmer encounters in Python: syntax error, logical error, and runtime error. Let us learn about them in detail. Syntax error. Syntax means writing the code following the rules of Python language. Syntax error is occurred when we violating the rules of Python language. This is the most common type of an error made by a programmer. If there is typing error, incorrect indentation, or incorrect arguments given in a function, then Python will not be able to interpret the instruction and will raise a syntax error. In IDLE, it will be highlighted by an arrow and then you can go to that line to rectify the error. Some of the examples of syntax error are logical error. This kind of error is difficult to find since the program will run correctly, but the desired output is not achieved. This happens if we give a wrong formula for the calculation to be done. Write wrong logic for the problem to be solved through the code. For example, to calculate the average. Preceding code produces a wrong output due to the logical error in formula. Let us take another example to find the perimeter of rectangle. Runtime error. Runtime error occurs during the execution of a program like wrong input or output errors, undefined object errors, division by zero errors. This type of error will halt the program execution unexpectedly. Example of runtime error is if A is equal to 5 and B is equal to 0, then it will display control statements. As you know that a program is a set of instructions given to a computer to do a specific task. The order of execution of these instructions controls the flow of a program. There are three important ways to control the flow of a program, which are interpreted by any programming language in a structured manner. These are sequential, selection, iterative. Let us learn about these in detail. Sequential statements. A step-by-step process of execution of code is called sequential flow of control. This is the default flow of execution of a program. It means that the computer will learn the code one line at a time starting from line 1, followed by line 2, and so on till it reaches the last line of the program. Let us take an example of making a mango smoothie. The steps will be 1. Put mango pieces in a mixer jar. 2. Add sugar. 3. Add milk. 4. Churn the mixer jar. 5. Pour in a glass. Let us do some more examples. Input first name and last name from the user and display full name. Algorithm. Start. Input first name. Input last name. Full name is equal to first name plus last name. Display full name. Stop. Flowchart. Start. Input first name, last name. Full name is equal to first name plus last name. Display full name. Stop. Source code. Output. Enter your first name, Suzanne. Enter your last name, Christopher. Hello, Suzanne Christopher. Welcome to the world of Python. Input length and breadth of a rectangle. Calculate the area and perimeter. Algorithm. Start. Input length, breadth. Area is equal to length multiplied with breadth. Perimeter is equal to 2 times length by breadth. Display area is area. Display perimeter is perimeter. Stop. Flowchart. Start. Input length, breadth. Area is equal to length multiplied with breadth. Perimeter is equal to 2 times length multiplied with breadth. Display area is area. Display perimeter is perimeter. Stop. Source code. Output. Enter length 5. Enter breadth 10. Area is 50. Perimeter is 30. Selection of statements. In Python, selection flow of control is achieved through conditional statements. In the conditional or selection statements, flow of control is changed based on a condition. We specify the condition in the program which evaluates to either true or false. If condition is true, then the block of statement written for true will be executed, and in case the condition is false, then the block of statements for false will be executed. Conditional statements are also called as branching statements as the program decides which statement to execute based on the result of the evaluated condition. A block is identified by using an indentation minimum 1 space. Ensure that all statements in one block are indented at the same level. Python mainly provides 3 types of conditional statements: if else, and if, elif, else statements. Let us learn about them in detail. The if statement. We use the if statement to do conditional programming. Condition with the if statement can also be written within the parentheses. However, it is optional to use parentheses. It is must to specify colon. After writing a condition with the if statement, the number of statements, also called as a block, written within if statement can be of any size. A statement or block of statement will be executed only when the condition is true. If the condition is false, then nothing happens. Syntax of the if statement. If, condition, colon, statements, where if is a keyword. Condition can be any relational or logical expression. Statements are always indented, can be single or a block. Program 1. To input the percentage of a student and award. Certificate of excellence. If the student gets more than 80%. Algorithm. Start. Input percent. If percent is more than 80, then display congratulations. Display you are awarded certificate of excellence. Stop. Flowchart. Start. Input percent. Is percent greater than 80? No. Stop. Yes. Display congratulations. Display yes. You are awarded certificate of excellence. Stop. Source code. Output. Enter your percentage 89. Congratulations. You are awarded certificate of excellence. Program 2. To input day of the week and in case it is Sunday, then extra cookie as a reward point to be given with the order. Algorithm. Start. Input weekday. If weekday is same as Sunday, then display reward point chocolate cookie free. Stop. Flowchart. Start. Input weekday. Is weekday Sunday? No. Stop. If yes, display reward point chocolate cookie free. Stop. Source code. Output. Enter day of the week. Sunday. Reward point chocolate cookie free. The if-else statement. When the condition is true, then the statements indented just below the if statement will be executed, and if the condition is false, then the statements indented just below the else statement will be executed. The else statement is optional and if required can be only one else statement in one if block. The syntax to use the if, else statement is if condition colon statements for true, else statements for false, where if and else are keywords. Condition can be any relation or logical expression. Statements are always indented and can be single or a block. Program 3. To input two numbers and display the bigger of the two numbers. Algorithm. Start. Input N1, N2. If N1 is greater than N2, then display N1 is bigger. Otherwise, display N2 is bigger. Stop. Flowchart. Start. Input N1, N2. Is N1 greater than N2? Display N2 is bigger. Display N1 is bigger. Stop. Source code. Output. Enter first number 34. Enter second number 45. 45 is bigger. Program 4. To input a number and display whether it is even or odd. Algorithm. Start. Input number. If number is divisible by 2, then display number is even. Otherwise, display number is odd. Flowchart. Start. Input N1. Is N1% 2 equals 0? Display odd. Display even. Stop. Source code. Output. Enter a number 23. 23 is the if, elif, else statement. When there are multiple conditions in a program, then it is handled by using elif statement. It means if the previous condition is not true, then try this condition written next to elif. If one condition is true, then the statements below it will be executed, and the rest of the conditions given using elif will be ignored. In case all the conditions written with elif are not true, then the statements written just below the else statement will be executed. The syntax of the if, elif, else statement is as follows. If condition 1, statements 1. Elif condition 2, statements 2. Elif condition 3, statements 3. Else statements executed when all above conditions are false, where if, else, elif are keywords. Condition 1, condition 2, condition 3 can be any expression. Statements 1, statements 2, and statements 3 are always indented, can be single or a block of statements. Program 5. To input two numbers and an operator from the user. Display the result calculated based on the operator entered. Algorithm. Start. Input N1, N2, op. If op is same as that of plus, then display N1 plus N2. Otherwise, if op is same as that of minus, then N1 minus N2. Otherwise, if op is same as that of multiplication, then display N1 multiplied N2. Otherwise, display wrong operator entered. Stop. Flowchart. Start. Input N1, N2. Is op is equal to plus? Yes. Display N1 plus N2. No. Is op is equal to minus? Yes. Display N1 minus N2. No. Is op is equal to multiplication? Display N1 multiplied N2. No. Display sorry invalid operator. Stop. Source code. Output. Enter first number 5. Enter second number 4. Enter an operator plus, minus, asterisk, multiplication only. colon. The multiplication is 20. Program 6. To input a number and check whether the number is positive or negative. Algorithm. Start input number. If number is same as 0, display you entered 0. Otherwise, if number is greater than 0, display you entered positive number. Otherwise, display you entered negative number. Stop. Flowchart. Start. Input number. Is number equal 0? Yes. Display 0. No. Is number greater than 0? Yes. Display positive number. No. Display negative number. Stop. Source code. Output. Enter first number -4. You entered a negative number. Nested if statement. Writing one if statement within another if statement is called nested if statement. Nesting of if statement can be up to any level. Indentation plays a very important role in identifying the levels. Program 7. To input billing amount and gender. If the billing amount is more than 10,000 and gender is female, then discount is 15%. Otherwise, discount is 10%. Calculate the billing amount accordingly. Algorithm. Start. Input amount, gender. If amount is more than 10,000, then if gender is same as that of F, then display amount after 15% discount is amount minus 0.15 multiplied amount. Otherwise, display amount after 10% discount is amount minus 0.10 multiplied amount. Otherwise, display sorry, no discount. Stop. Flowchart. Start. Input. Amount. Gender. Is amount greater than 10,000? No. Display sorry, no discount. If no, is gender F female? Yes. Display amount is equal to 0.10 multiplied amount. If no, display amount is equal to 0.15 multiplied amount. Stop. Source code. Output. Enter billing amount 12,000. Gender M. Male. Amount after 10% discount is 10,800. Program 8. To input a number and check whether it is multiple of 5 or not. This check is valid only for positive numbers. Algorithm. Start. Input number. If number is greater than 0, then if number is divisible by 5, then display it is multiple of 5. Otherwise, display not divisible by 5. Otherwise, display sorry, invalid number. Stop. Flowchart. Start. Input number. Is number greater than 0? No. Display invalid number. No. Is number modulus 5 equal 0? Yes. Display not multiple. No. Display multiple of 5. Stop. Source code. Output. Enter a number 34. 34 is not multiple of 5. Iterative statements. In Python, the process of repeating a set of instructions based on a condition is called loop. There are two types of loop in Python: for loop and while loop. Let us learn about them in detail. The for loop. The for loop is used to repeat a set of instructions for a fixed number of times. It means the number of iterations are known or definite before we start with the execution of a loop. Therefore, the for loop is also known as definite loop. Indentation of statements is must to specify the block of statements to be repeated using the for loop. There are commonly two different ways of using the for loop. Using sequence. In this type of for loop, a sequence of values is used on which the loop iterates. The syntax to use the for loop with the sequence is for counter variable in sequence statements, where for is a keyword. Counter variable is any identifier that keeps a count of the loop. Sequence is any values like integer, string, list, etc. Statements are always indented, can be single or a block. Different examples of for loop are commands, output, for I in 1, 2, 3, 4, print I, 1, 2, 3, 4. For words in hello, friends, how are you, colon. Print words, hello, friends, how are you. For alphabets in hello, colon. Print alphabets, H, E, L, L, O, exclamation. Using the range function. The range function is an inbuilt function that is used to generate a set of values between the specified range. For variable in range start n+1 step colon statements, where for, in, and range are keywords. Start, end, and step are parameters of range. Function and will always be integers. Start is a starting value of loop and end is an ending value +1 of loop. Step is the number of steps taken to reach the end value. If only two parameters are used, then step value becomes 1 by default. If only one parameter is used, the start becomes 0 and steps becomes 1 by default. If start greater than end, then step is a negative integer should be given. If start less than end, then step is a positive integer. If start greater than equal to end and step value is not specified, then it assumes as positive, which is an invalid condition to run a loop, so the loop will not execute at all. Different examples of for loop with a range function are commands, output, for count in range 1, 6, 1, print hello, print program ends, hello, 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 program ends. For variable in range 1, 10, 2, colon, print variable end minus 1, 3, 5, 7, 9. For count in range 1, 10, colon, print variable end 1, 2, 3, 4, 5, 6, 7, 8, 9. For variable in range 10, print variable end equal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For variable in range 5, 0, minus 1, print variable end equal 5, 4, 3, 2, 1. For variable in range 5, 5, colon, print variable end. No output. For variable in range 5, 3, colon, print variable end equal, no output. Hash program to generate alternate numbers for the given range. Start equals to int, input, enter starting value. Ends, int, input, enter ending value. For variable in range, starts, ends +1, 2, colon. Print variable end equal. Enter starting value 5. Enter ending value 10, 5, 7, 9. The while loop. The while loop is used to repeat a set of instructions as long as the condition is true. It means when the number of iterations are not fixed or indefinite. before we start with the execution of a loop. It is therefore known as indefinite loop. Indentation of statements is must to specify the block of statements to be repeated using while loop. This loop is also called an entry-controlled loop as it checks for the condition in the beginning only. If the condition is true, then the body of the loop will be executed. If the condition is false, then it will not be allowed to enter within the loop and it stops. Syntax of the while loop is while, condition, statements, where while is a keyword. Condition is a criterion to repeat the instructions. The instructions repeat till the condition is true. As soon as the condition is false, the control exits from the loop. Statements are always indented, can be single or a block, and are repeated till the condition is true. Different examples of while loop are commands, output, count equals to 1, while count less than equal to 5, print hello, count plus equal to 1, print program ends, hello, 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 hello. Program ends. I equal to 1, while I less than 6, print I plus equal to 1, 1, 2, 3, 4, 5. Hash input a number and check for even or odd. The whole process should continue till the user wants answer equal to y. While answer equal y, number equal int, input, enter a number, colon. If number 2 equals 0, print number is even, else print number is odd. Answer equal, input, press y to continue, colon. Print program ends here. Enter a number 3. 3 is odd. Press y to continue, y. Enter a number 6. 6 is even. Press y to continue, y. Enter a number 12. 12 is even. Press y to continue, n. Program ends here. Hash display the digits of a number in a reverse order. Number equal int, input, enter a number. While number greater than 0. R is equal to number 10. Print R. Number /10. Enter a number 594. 495. Program 9. To print the sum of first 5 natural numbers. Algorithm. Start. Number 1. Sum 0. While number is less than 6, sum is equal to sum plus number. Number equal number plus 1. Display sum is sum, stop. Flowchart. Start. Number 1. Sum 0. Is number greater than 6? No. Display sum is sum, stop. If yes, sum is equal to sum plus number. Number is equal to number plus 1. Source code. Output. Sum is 15. Lists in Python. List is a collection of heterogeneous data arranged in a sequence. The values can be of any data type like string, integer, float, objects, or even a list. Each value in a list is called an element and its position in a list is referred by an index number. The number of elements in a list will make the length of a list. All the elements in a list are separated by comma and enclosed in square brackets. List is a mutable data type. In Python, as the content of the list can be added, modified, or deleted by the user anytime throughout the code. A number of operations can be performed on the list by using a few built-in list functions, which we will study in detail in this chapter. Important features of lists. Based on the above definition, the list has the following important features. It is mutable data type. It is an ordered sequence of values. Each element is separated by a comma and enclosed in square brackets. Each value or element is accessed by an index number. The values can be added, modified, or deleted by the user throughout the program. It stores the values of different data types. Creating a list. A list is created by enclosing the values within square brackets. Each value or element is separated by a comma and stored under a common name. These values can be of different data types. The name follows the rules of naming conventions for identifiers. For example, examples, commands. Creating an empty list. List1 is equal to square brackets. Creating a list with single value. List2, square brackets 56. Creating list of friends. Friends, square brackets, double quotes Saisha, double quotes Advika, double quotes Arshia. Creating list of marks. Marks is equal to square bracket 92, 91, 89, 95, 93. Creating list of students with roll number and percentage. List of mixed values. Students, square bracket 21, double quotes Gunjan, 94.5, 34, double quotes Rohit, 91.3. Creating a list within another list. Section is equal to square bracket double quotes A, 25, double quotes English, square bracket double quotes B, 34, square bracket close, square bracket double quotes C, 37, 56.7. Creating a list with repeated values. L1 is equal to square bracket 10 times 5. Hash L1 will have 10, 10, 10, 10, 10. Creating a list from another sequence or string using list function. Alpha is equal to list, double quotes hello, hash string converted to a list, hash output will, single quotes H, single quotes E, single quotes L, single quote L, single quotes O. Values input from the user in a list. L1 is equal to list, input, double quotes, enter numbers, colon. Accessing the elements of a list. The elements of a list can be accessed by using its index number starts with 0. There are two different ways of using the index number. Forward indexing. The index numbers begins with 0 till length 1 and we refer the elements from left to right. Negative or backward indexing. The index number begins with -1 till minus length and we refer the elements from right to left. For example, L1, square brackets, single quotes, P, single quotes Y, single quotes T, single quotes H, single quotes O, single quotes N, square bracket closed. Forward indexing. 0, 1, 2, 3, 4, 5. P, Y, T, H, O, N. Backward indexing. -1, -2, -3, -4, -5, -6. Each element can be accessed by using list name, index number. Commands. Output. Traversing a list. Traversing means visiting each element and processing it as required by a program. We use a loop to traverse a list. There are different ways to visit each element as shown below. Commands. Output. Using plus operator with list. The addition operator is used to concatenate the list with another list. Remember that both the operands on either side of addition operator have to be a list only, otherwise it gives an error. For example, Commands, output. Using multiplication operator with list. The multiplication operator is used to replicate a list specific number of times. With multiplication operator, one operand has to be a list and the other should only be an integer. Otherwise, it will give an error. For example, commands, output. Comparing the lists. The comparison of the lists is done using comparison operators. These operators compare the elements in lexicographical order. For example, if corresponding elements are same, it goes to the next element and so on until it finds elements that differ. For example, slicing a list. Slicing a list means accessing a specific portion of a list. This can be done by using a range of values with start index number, end index number with colon in between. We can use both forward index and backward index to specify the range of slicing a list. Some important points to consider to do slicing in a list are elements from beginning to a range, list square bracket colon index or colon dash index. Elements from specific index till the end. List, square bracket, index, colon. Elements within a range. List, square bracket, start index, colon, end index. Elements within range using step value. List, square bracket, start index, colon, end index, colon, step value. Whole list in forward order. List, square bracket, colon. Whole list in reverse order. List, square bracket, colon, colon, -1, square bracket. For example, word, education, forward indexing, 0, 1, 2, 3, 4, 5, 6, 7, 8. E, D, U, C, A, T, I, O, N. Backward indexing, -1, -2, -3, -4, -5, -6, -7, -8, -9. Examples, commands, output. To display the whole list. Displays the alternate elements of the given list. To display single quotes E, single quotes D, single quotes U from the above list. To display single quotes C, single quotes A, single quotes T from the above list. To display single quotes O, single quotes I, single quotes T from the above list. To display the list in reverse order. Adding new elements to a list. There are 3 different functions used to add elements in an existing list, which are append, extend, and insert. Let us learn about them in detail. The append function. The append function appends a single element with the given value, any data type, at the end of the list. We use this function in a loop for adding multiple elements. With a single append function, the length of the list will increase by 1. Syntax of append function is list.append item, where item can be any value like number, string, list, etc. Examples are commands, output. The extend function. The extend function is used to append multiple values at a time in a list. Syntax of extend function is where iterable value can be a list. Examples are commands, output. The insert function. The insert function is used to add a single value at a specific position in an existing list. The length of the list will increase by 1. Syntax of the insert function is examples are commands, output. Modifying existing values in a list. List is mutable, so data can be easily modified by overwriting a new value to an existing value in a given list by using an assignment operator is equal to. Syntax to modify existing values in a list is, for example, commands, output, removing elements from a list. There are two different functions used to remove elements in an existing list, remove and pop. Let us learn about these functions in detail. The remove function. The remove function removes the first occurrence of the element with the specified value. It means only one value can be removed at a time, even if there are duplicate values in the list. If you wish to remove multiple values, then this function can be used within a loop, where it repeats itself a specific number of times. Syntax of the remove function is, for example, commands, output. The pop function. The pop function removes an element from the list based on the index number specified in the function and returns the deleted value. In case no index number is given, then by default it removes the last element from the list. If we try to remove an index number which does not exist, then it gives an index error. For example, commands, output. Some other functions used with list. There are some other functions also available to use the list which are as follows. Len. This function returns the length of a list. For example, output will be 5. Clear. This function removes all the elements of the list in one go. It empties the list, but the empty list still exists in Python, which can be used later to fill the values. For example, output will be square bracket. Reverse. This function reverses the content of the list, double quotes in place. For example, output will be square bracket, single quotes E, single quotes D, single quotes C, single quotes B, single quotes A. Sort. This function sorts the list in ascending or descending order. This is done in the list itself and works for the list with values of the same data types. For example, double quotes Chennai, double quotes Delhi, double quotes Kolkata, double quotes Mumbai. Output will be square bracket, double quotes Mumbai, double quotes Kolkata, double quotes Delhi, double quotes Chennai. Index. It returns the index number of the value given in the function. For example, output will be value error. It returns value error, exception if the value is not found in the list. Count. This function counts the number of occurrences of the specified value in the given list. If the value doesn't exist, then the function returns 0. For example, output will be 2. Output will be 0. Hash 10 does not exist in the list.